In this video, we're going to apply the fundamental theorem of calculus to evaluate the integral of a piecewise continuous function. So the question here is to evaluate the integral from 0 to e f of x dx. The function f of x is given by root x on the interval from 0 to 1, 1 over x on the interval from 1 to e. And we've graphed it here on the right. So since the function f of x is made up of two piecewise continuous functions on the interval, closed interval 0 to 1, union 1 to e, we can apply the fundamental theorem of calculus to compute the integral from 0 to e f of x dx. So we're going to split up the integral from 0 to e f of x dx as the sum of two separate integrals, as integral from 0 to 1 f of x dx and integral from 1 to e f of x dx. But the function f of x is equal to root x on the interval from 0 to 1, and the function f of x is 1 over x on the interval 1 to e. So let's integrate 0 to 1 root x dx plus integral from 1 to e 1 over x dx. And the integral of x to the 1/2, reversing the power rule, that's going to be x to the 1/2 plus 1, that's 3/2, divide by 3/2 from 0 to 1. And antiderivative of 1 over x is going to be log of absolute value of x from 1 to e. All right, let's flip the denominator. We get 2/3 x to the 3/2 from 0 to 1 plus, and we don't need the absolute value because x is a positive number. X is between 1 and e. For this reason, we can drop the absolute value and write this as log x, evaluated from 1 to e. All right, let's do the computation. We get 2/3 times 1 to the 3/2 minus 0 to the 3/2 plus log e minus log 1. We get 2/3 times 1 to the 3/2 is just 1, 0 to any power is 0, and log of e is equal to 1, log of 1 is equal to 0, so we get plus 1. The answer is 2/3 plus 1, and that works out to 2 over 3 plus 3 over 3, that is 5 over 3. Now it's important to realize that the first integral from 0 to 1 root x dx was computing the area under the graph of y equals root x from 0 to 1. And the second integral from 1 to e 1 over x dx, was computing the integral from 1 to e under the function y equals 1 over x. All right, let's look at another example. In this question, we have evaluated the integral from 0 to 2 absolute value of x squared minus root x dx. So the solution here is to evaluate the above integral, but to do that, we need to find out the intervals on which x squared is larger than root x or x squared is less than root x, so that we can split up the integral into the sum of two separate integrals over two separate intervals. So the first thing we're going to do is make the inside of the absolute value equal to 0. So that's x squared minus root x equal to 0. And we're going to solve for x. So we get x squared is equal to root x. Let's square both sides. We get x squared all squared is root x all squared. That's x to the 4th is equal to x. Now bring the x on the left-hand side. We get x to the 4th minus x equals 0. Let's factor out the x. We get x times x cubed minus 1 is equal to 0. Now we have to apply the difference of cube. Recall that a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. All right, so what we get is x times x minus 1 times x squared plus x plus 1. Make this equal to 0 and solve for x. Clearly, x equals 0 is a solution. X minus 1, make this factor equal to 0, and we get x equals 1. So we have x equals 0 and x equals 1. Now we need to make this part, the quadratic factor, x squared plus x plus 1 equal to 0. So let's try that. We have x squared plus x squared plus x plus 1 equal to 0. Apply the quadratic equation. X is equal to -1 plus or minus root b squared, that's 1 squared, minus 4 times AC, 4 times 1 times 1, all over 2a, that's all over 2, and we get negative 1 plus or minus root of 1 minus 4 is negative 3 over 2, and we can't have root of a negative number. This is not possible. So we can now rewrite x squared, absolute value of x squared minus root x, as minus x squared minus root x on the interval x between 1 and 0, and x squared minus root x on the interval between 2 and 1. So this is a way of removing the absolute values so we can split it up into two separate integrals and apply the fundamental theorem of calculus to solve the integral. All right, so the integral from 0 to 2, x squared minus root x, absolute value dx, is equal to integral from 0 to 1 minus x squared minus root x dx plus integral from 1 to 2, x squared minus root x dx. Now is the part where we have to solve these integrals. All right, so what we have is equal to minus, looking at the first integral, that's going to be, reversing the power rule, x cubed over 3, minus integral of root x is going to be x to the 1/2 plus 1, 1/2 plus 2 over 2, that's 3/2, and divide by 3/2, that's the same as multiplying by 2/3, from 0 to 1, plus integral of x squared is going to be reversing the power rule, that's x cubed over 3, minus x to the 1/2 plus 1, that's x to the 3/2, divide by 3/2, that's the same as multiplying by 2/3. And that's evaluated from 1 to 2. All right, so now we get negative. Putting the upper limit 1 in, we get 1/3 minus 2/3 minus, plug 0 in, 0 to any power is just 0, minus 2/3 times 0, that's also 0, plus, plugging the upper limit 2 in, we get 2 cubed, divide by 3, minus 2 over 3, times 2 to the 3/2. Now subtract the lower limit, that's going to give us 1/3 minus 2/3. So let's simplify all of this. We get negative 1/3 minus 2/3 is negative 1/3. And that's plus. And here we have 2 cubed over 3, that is 8 over 3, minus 2 over 3 times 2 to the 3/2. And minus 1/3 minus 2/3 is negative 1/3. Simplifying further, we get 1/3 plus 8/3 minus 2 over 3 times 2 to the 3/2. Minus minus will give us plus 1/3. So we got 1/3 plus 8/3, that's 9 over 3 plus 1 over 3. That's going to give us 10 over 3 minus 2 times 2 to the 3/2 divide by 3. Let's take a common denominator. We get 3, and that's 10 minus, and 2 times 2 to the 3/2, we got the same base. Let's add up the exponents. 1 plus 3/2, that's just going to be 2 over 2 plus 3 over 2. That is 5 over 2. That's 10 minus 2 to the 5 over 2. All right, so what we have evaluated, what we have calculated here is the integral from 0 to 2, absolute value of x squared minus root x dx. We've evaluated this to be 10 minus 2 to the 5/2 divided by 3. If you decimalize this, it's going to be approximately 1.448. And this actually represents the area under the curve. So let's go back to that diagram. So what we're really looking at is the first integral is the area from 0 to 1, and the second integral is the integral from 1 to 2. And the value that we find is represents the area under the curve. All right, thanks.